If you want real-life Ready Player One or real-life Ordinal Scale, it all starts with tracking. So let's go ahead and track this lightsaber and make a simple game. Let's write a program that can track a lightsaber for us. So you and I, we know what a lightsaber looks like, right? Well, we need to instruct our program how to track a lightsaber. So in order to do that, we can use something called OpenCV. With OpenCV, we can instruct our program to look for the glowing object in the image it is analyzing. So let's go ahead and start coding our program. Okay, we wrote our program. Now let's go ahead and test it out on this image. Whoa, okay, so obviously there's some problems. So the problem is that our program thinks there are many lightsabers in this image, which is not the case. But it's okay, our program is just a baby right now, and we can teach it how to recognize a lightsaber. So let's go ahead and do that. Okay, so I went ahead and wrote a program that can help us identify what is actually the lightsaber in a frame. So the first thing we're going to do is we're going to ignore all these tiny little possible lightsabers, and OpenCV can allow us to do that pretty easily. So let's go on to the next step. Okay, here we have many possible lightsabers, and we're going to go through each blue rectangle and tell the program whether it's a lightsaber or not. The current rectangle we're looking at will be highlighted in yellow. We're going to hit the Y key to tell it that yes, it is a lightsaber, or the N key to tell the program no, it's not a lightsaber. If it's not a lightsaber, our program will mark it with a red line. So right now we are looking at the actual lightsaber in the image. So I'm going to hit the Y key to tell the program that this is a lightsaber. And now I'm going to hit the N key for the rest of the rectangles. And then I'm going to run my program one more time. And bam, there you have it. We have a program that can accurately predict a lightsaber in an image. The more we do this, the better ability in predicting lightsabers in an image our program will have. Now, a live video stream is just a series of images, so our code will be able to work for a live stream, which is important for a game. Now, let's go ahead and see how robust our code is. We're going to go ahead and take our system to the holodeck. The holodeck is the name I have given to our experimental room. Here, we'll have plenty of space to swing our lightsaber around. Let's test our program on this video where we have a fast-moving lightsaber. Now our program seems to be tracking the lightsaber just fine, but if we slow down the video, you can see where our program fails to properly identify a lightsaber in a frame. Now the reason this happens is because of something called motion blur. When an object is moving really fast, what happens is that a camera is not able to properly capture an image of that moving object. So you get something called motion blur. This is something called lightsaber blur. And in our case, this is what our lightsaber looks like when it's moving too fast for the camera. So what we need to do is we need to have our program recognize this saber blur as a lightsaber. So one of the things we can do is we can send our program back to school. And we can also get a camera with a higher frame rate capture. camera with a really high frame rate will allow us to capture moving lightsabers in a way that shows what a lightsaber really looks like. So let's go ahead and update our code and let's see what the video looks like now. Okay, it looks much better this time. As you can see, our program is now better able to determine what a lightsaber is in the frame, whether it's moving or not. So now that we can track a lightsaber replica in real time, we can create a game. We can calculate the position of the endpoints of the lightsaber and pass this information to a game engine. If the game engine knows what the position of the lightsaber is supposed to be at any time, then we can create some really cool games similar to what you are seeing here. Now, the most important part in making a game in augmented reality and virtual reality for a lightsaber replica is the tracking. Now, that is something that I've already taken care of. So the next step is something that can be delegated to a game developer in Unreal Engine, for example. So the next best step really is to hire an Unreal Engine developer to help me create the rest of the game. And of course, I would need the funding to hire a competent Unreal Engine developer. But since it's only me right now, I can do the basics of a video game using primitive graphics. So let's go ahead and get started. So for the very simple AR VR demo game that we're going to do today, we're going to implement something called collisions. In our case, we want something called align rectangle collisions, and this will represent when the line or lightsaber collides with our basic enemy, which is a rectangle. So in order to implement a line rectangle collision algorithm into our game, I'm going to do something called a pro software developer move. Now our game is ready for line rectangle collision or lightsaber rectangle collision. Here we go. Okay, as you can see, the collision works pretty well. So what's happening is we have a line, which is the lightsaber line, making a collision with the red rectangle, which is able to detect just fine. Next, we're going to set up our gaming environment, which is going to be pretty much me facing a giant selfie mirror. We're going to have a camera, a lightsaber replica, and a projector, which is going to project a giant selfie screen right in front of me. So this is how the game is going to work. You're going to start off with the player, which is you, and then you are going to have a red rectangle show up. This red rectangle is your enemy, so you need to attack it. And once you successfully attack your red rectangle enemy, you'll get rewarded with points. Now, to prevent spamming with the lightsaber, what I'm going to do is I'm going to have the player surrounded by different colored rectangles. Now, the green rectangle is a friendly rectangle. This rectangle is just here to say hi and give you some points as it disappears. If you strike our friendly green rectangle, you will be penalized. Alright, so I'm pretty happy the way this turned out. Next time I would like to have enemies that fight back. So on my next video you can expect the enemies to fire laser projectiles at the player. In this video, we did a front view selfie perspective for the player. Next time I'm going to do a top-down perspective and then a third-person perspective. If you like this video, be sure to subscribe so you can see more videos like this in the future. I'll see you next time.